Good morning, student. So, in this video, I am going to discuss a particular question. The question is when white light, in case of white light interference, that is, when white light is incident on the two slits of Young's double slit experiment, then, as you know, the central bright fringe is white. And then, what is the next color? What is the nearest visible or prominent color to the bright fringe or bright spot? So what is the color that is visible prominently nearest to the bright spot? Okay, so for that, this is, suppose white light is incident, LIGHT is incident, and this is the two slits and this is the screen. So as you know, we always assume the distance between the screen and the sources as capital D, and this is the distance between two sources as small d, isn't it? Okay, now this is the midpoint of the two slits, and if we draw a perpendicular on the screen, here we get to see the bright spot. So all the colors from the two sources, will come and incident at this point. So here basically all the colors, all the vibgyor, all the wavelengths will come and incident with phase difference 0. That is why all the color will be actually make constructive interference here. So basically they will again merge, so we get to see a bright spot here, isn't it? So let me draw the screen. Suppose this is the screen, again I am drawing. Now what I will do is, I will show you that the disturbance or the intensity that is produced due to individual colors. First, I'll start with the color violet. As you know, the intensity curve is proportional to cos square, isn't it? So it looks like this, not sine or cos, it is cos square. Okay, so what I am going to do is, first I'll take the only one only one, I mean from 0 to 2 pi only. Okay, so this is the intensity distribution of or due to violet. So here definitely the this is the distribution, intensity distribution for violet color. Now similarly, what I'll do, let me, as you all know that the beta, fringe width beta is equals to d lambda by d, and as we move on from violet to red, the uh, lambda or the wavelength is greater or greater for red, isn't it? The lambda r is the largest among this figure. Okay, so lambda for violet is the smallest. Fine. So what I'll do right now is, I will make or prepare, this is for violet. Similarly, I'll prepare for indigo. For indigo, it will be little large, and definitely I'll change the color from violet to indigo. Here indigo is not visible to me, so what I'll do, give me a little time. Suppose from here, let me choose it. Okay, you just assume that yes, it is indigo. Then blue I'll take blue. So how to do it? So I'll take blue color. Again the blue is Okay, let us take it as blue. Then we'll take green. Then we'll take green. This is the intensity distribution for green. Then I'll take for orange. See, now I am not taking all the colors. That is little, that is, that will not help us also. Then we will take red. Okay, where is the red? This one is the red. So see, this is the distribution of intensity, but uh, the wavelength is greater for red. So I, and this is the wavelength from, as you know, the wavelength is the lowest, or among this Vibgyor, the wavelength is lowest for violet. So for indigo, it will be little large, and I already made it little large. Then for blue, it will be more large. For green, it will be more large, and for orange, it will be again more large. For red, it is more large. Now let us remove it. What I'll do, I'll take here, then I'll take the indigo distribution, intensity distribution to here, then I'll take the intensity due to blue here, then green here, then orange here, then red here. See, here all the Vibgyors are incident at this point, that is at the central bright, at the same phase, that is why they will interfere constructively. So we will find a white spot on the green on the screen, that is why I am making a white spot here. Now you can see I made a white spot here. Okay, but as we will move on to the right or left direction, here, for example, suppose here all the colors are not incident at the same phase, they have little phase difference, that is why we will see blur, there will be no prominent color, isn't it? Now what I will do is, see, suppose this is the distribution, intensity distribution for violet, isn't it? See, I want to place one more violet distribution, that will definitely be placed here. Why? See, the violet, the earlier distribution of violet was this, and the next one will be like this only, isn't it? Okay, so what do we see here? See, I want to see where is the destructive interference due to violet. Due to violet, the the destructive interference will take place at this point, isn't it? Okay, so if I focus at this point, there will be no violet color due to the destructive interference of violet color only, isn't it? So at this point there will be no violet color. At the same time, as I can see, the intensity of the red color at this point is maximum. As you can see, the intensity of the red color is maximum, then orange, then green, then blue, then indigo, then violet. So what I mean is, this line is representing actually the intensity. This represents actually intensity. Now if we focus at this point here, as we can see, the intensity of red is the greatest among this VIBGYO. So we will see a red color nearest to the central bright spot. I am not saying central bright fringe. I am saying central bright spot. So red color is the prominent color whose intensity will be prominent, will be visible prominently nearest to the central bright spot. I hope this question or the solution, the concept is clear to you all.